Hey, hi everyone, welcome to a brand new video. So this video is going to be a in-depth and complete Python Firebase course. So it will follow a series of Firebase features, starting with authentication, so logging in, creating new accounts, different types of user management, as well as storage. So you'll be able to store and upload files to the internet, as well as download them, read from them, and store them in these different locations. And finally, and most importantly, we're going to access the Firebase Realtime Database. So the Realtime Database, we're going to create some data within the database, work with it, create it, read it, update it, and delete it. So the different CRUD applications. Now, the library we'll be using is the Pyrebase library. So it's a very popular library for the Firebase API with Python. So it is very popular. So we're going to explore every single aspect of it and then just really get to know everything that's in it. So without further ado, let's just get started. So the first thing we're going to start with is the authentication part. So we're going to start with authentication and then move on to something else. So let's just get started. So first of all, we must go to console.firebase.google.com. So this is where all your Firebase projects are stored. You can access your different Firebase projects. So these are different dummy projects, you could say, from different tutorials I've done over the time of my channel. Now for this tutorial, we're going to create a new project. So we're just going to add project and give it a name. So the name we're going to give the project, let's just say Firebase course. And then we're going to continue. We can enable Google Analytics. This is no issue, but we will not be using them for this project. Now we can create the project and wait for it to load. Now, while we wait for the project to load, we can go back to PyCharm. So this is an empty project with PyCharm. I just created it empty, nothing inside. And the first thing we're going to do is actually install the library that we're going to be using. So if we go to the terminal, all we have to do is pip install Pyrebase 4. Now this is the library we're going to be using. Now you may have heard of simply Pyrebase, so just Pyrebase, or Pyrebase 4. Now the truth is that there is pretty much no difference. So let me just enter here. I already have it, so requirement already satisfied. However, in your case, you would wait a couple minutes for Pyrebase to be downloaded. So let's just talk about the difference between Pyrebase and Pyrebase 4. So let's get that out of the way so that there's no confusion. So Pyrebase 4 is essentially a GitHub fork of the original Pyrebase library. Now, the thing about the original library was that it stopped being maintained and some errors started showing up and no one was there to actually fix them. So someone forked it, created Pyrebase 4 and fixed all the errors while leaving the code the exact same. So that nothing will differ in your code. So if you're choosing to move from Pyrebase to Pyrebase 4 and you already have existing Firebase code with that library, there's no problem because the code syntax is the exact same. So you can migrate by doing nothing other than uninstalling Pyrebase and installing Pyrebase 4. So that's just a note. Keep that in mind if you're interested in why or what the difference is between these two libraries. Alright, so we just installed Pyrebase. Now going back to our Firebase console, so our project is now ready. So we continue, and this should take us to our project overview or our project dashboard. Now this is where we have access to a variety of Firebase features, namely authentication, the Cloud Firestore, which is another type of database aside from real-time database. We have analytics for crashing, we have performance analytics, we have testing, we have cloud messaging, so which you can use this for the push notifications that you send to your applications. Now for Python, for this application, for Pyrebase specifically, so Pyrebase only supports the authentication, the database, as well as the cloud storage. So this is what we'll be exploring throughout this course. Now, so let's just actually understand what we have here. So like I said, project overview. Here we have the features, so authentication, database, storage, hosting, and a bunch of other things. All right, now let's go back to PyCharm and actually see what we have. So going back to PyCharm, let's create a new empty Python file. So let's just name this main.py or any other name if you want. So we're going to start off by importing Pyrebase. So you would import Pyrebase actually and not Pyrebase 4. And that's what I meant when I said the code is very easy to migrate from one instance of this library to the other because the code is the exact same. So now that we've imported Pyrebase, here's one thing we have to do. We have to add this application to this app. So we want to add the Firebase project to our application. We want to initialize a new application. To do so, we have to go back to the console, go back to our project, And here we have get started by adding Firebase, to your app. So you have iOS, you have Android, you even have Unity, and you have web. So for Python desktop applications, you're best off using web. So you would go to web, you would give your app a nickname, so Firebase course, you would register your app. There's no need to set up Firebase hosting. So as you wait for it to register, a bunch of credentials are going to show up. So this information right here is what you'll be using to connect to this application. So you take this part and you copy it. Now you can continue to console, there's no issue, so you're back here. Now going back to PyCharm, you want to be able to connect to this application, so you just Firebase config, and then you create a new dict and you paste this information right here. So what this dict does is that it basically stores your configuration credentials for Firebase. So this is what connects you to this application, and this is what enables you to be able to talk to this Firebase on the cloud and then just perform all sorts of operations with it. Now, one thing to keep in mind is that for Python, you must change these into strings because it will not understand them and will show you an error otherwise, because it will consider them as variables. So this is just some Python dict syntax for you. Now, if you're not familiar with Python dicts, so this is basically what they are. They're a series of key value pairs where the keys and the values, where the keys specifically, are strings, and the values can be anything but from a string to an int to a boolean. Alright, so this is a Python dict with our Firebase configuration credentials. Now to initialize an app, so all we have to do is Firebase and say it's equal to Firebase.initializeApp, and you would give it the Firebase config variable. Now by giving it this variable, you're telling it I want to initialize an app with these configuration credentials, with this information. And by doing so, you're able to initialize an app to that specific instance, to this project that you just created. Alright? Now here's the thing, so with Pyrebase, to connect to the database, all you have to do is just db or whatever variable name you want and say firebase.database or auth, and it's firebase.auth. Now there's no need to be worried about this right now because I'm going to explain every single one of these features in depth in this video. So this is how you basically initialize something that will talk to each and every one of these. Now we said we're starting with auth, so if you want we can comment these out for future reference, or we can probably leave them and just not use them. So here we have the authentication. Now that I'm connected to authentication, let's just start exploring it through Firebase so I can tell you exactly what it is, how we're doing it, and what sort of things are related to it. So going back here, now this is our project overview. We want to go to authentication. So let's go to authentication. So by authentication, we mean signing in, signing up, and all that. So managing users. And the way we manage users is usually when you have an application, you would either do it through an email and a password. So you obviously know this because you live on the internet and you know exactly how the internet works. So you either use an email and a password, or maybe you sign in with Facebook or sign in with Google or whatever. So now we're going to set up a sign-in method. So by going here, and we have a different bunch of things that we can enable so we can use Firebase to sign up with. Now this is really interesting because you can sign in with Google, Facebook, Twitter, GitHub, play games, Microsoft, Apple. You can even sign in anonymously. Now for this tutorial, for Pyrebase, we're going to stress on email and password sign-in. However, in a future video, perhaps I can have a more detailed authentication video on every single one of these different features. So the first thing we have to do is we have to enable the email and password sign in. So this way we'll be able to have users using their email and password. So going back to users. So this is where it sort of looks like. So this is sort of like a table, though you can't really see it, with a bunch of columns. So here you would have different users and the last time they signed in, when that account was created. You can add users manually. So here I can create a dummy, so dummy@mail.com, and I can give it a password of 1, 2, 3, 4, 5, 6, 7, 8, and then I can add a user. By doing so, I just manually created a user. So this user was created on July 23rd. It has this sort of email that identifies it. Providers, meaning with what did I use to sign in. So I used with email, not with Google or Facebook or anything else, as well as a user ID. Now, we signed in, we did not. So we just created this user into this authentication database, you could say. That's why there exists nothing here concerning the sign-in part. Now, Okay, so we know how to create it manually, but how helpful is that? You're not going to go ahead and create users manually for every single application that you own. So you want users to be able to do so through the code itself. So let's just code that. Let's do it. So for this application, for this project, we're going to do everything through the command line just to keep it simple, because I don't want to I don't want to impose a certain GUI library on you, so not a certain GUI module. So I want everyone to be able to access and use this project without having to download, let's say, Kivy or PyQt5 or anything else to make a graphical user interface. So we'll do it through the command line. All right. So here's what we have to do. What we're going to do is that we're going to ask our user to sign in with email and password. So here's what we're going to do. So we're going to say email, and we're going to ask for input and say enter your email, and then password, and we're going to ask for input, and then we're going to enter your password. All right, and we can have this as part of the login. So let's just comment it so we can keep everything separated. And we can even separate this from everything else by saying this is the authentication part of this tutorial. So we ask for the email and password. So what we need to do now, since we have an auth variable here, and this is connected to the Firebase auth, like we said, right? So all we need to do in this case is auth dot sign in with email and password. And you would give it the email variable, and you give it the password variable, and you're done. So this is how you do the authentication sign in with email and password. Now, if you want to try it out, here's what you can do. So let's just run this and run main. All right, so enter your email. So let's just try to sign into the email we just created manually in the database. So let's say dummy@mail.com. So that's what I believe we did. Now enter your password. So 1, 2, 3, 4, 5, 6, 7, 8. Now we enter, and nothing happened. So I should have put a print statement after it to say successfully logged in, but we pretty much just managed to sign in. Now, if we want to check, we can go back here to the table. We can reload by using this refresh button, and it says that we signed in July 23rd, 2020, which is today. So if you check my calendar right here, it's July 23rd, 2020. So this is how we managed to sign in from the Python code. Now, what we can do is that we can add a print statement here to add successfully signed in. Now, if we run it again, so let's just do the same thing. So dummy@mail.com, and then 1, 2, 3, 4, 5, 6, 7, 8. So successfully signed in. Now, what would happen if I just wrote an email that doesn't exist, or perhaps a wrong password? So let's just say fakemail@mail.com, and then pretty much any password. And then I enter. I get an exception, and this exception says email not found. So this is the message. Otherwise, if I typed in a wrong password, so let's just say dummy@mail.com, but I wrote in a wrong password. Now I enter. Now here the message is invalid password. So in all these cases, it's throwing an exception. Now the way we deal with exceptions with Python is that we try and accept. So let's just try and tab this here. And then we're going to accept. And when we accept, we're going to use this exception to just print invalid user or password, try again. All right, so now that we have this, now if we run it, and then I also try to sign in with a fake password, so dummy@mail.com, and then I enter invalid user or password, try again. So this way we managed to actually catch the exceptions in case the login part is wrong. So that's pretty much it for the login part. Now what we're going to do is we're going to do the sign up. Let's just move this. So we're going to do the sign up part. Now sign up is pretty much essentially the same. So we're going to get the email and password from the user. We can even ask to confirm password if we want to be creative. So let's just say input confirm password. So if you just want to be it's just to make things interesting. And then all we have to do is we have to create user with email and password. So email, comma, password. All right, but I want to check if the password matches the confirm pass. So we're just saying we're making sure the two strings are alike. And then I would create a new user. So let's just run it. And then let's just actually comment this part out right now. Okay, so now that we've commented the login part so that doesn't bother us, we can run it. And then, so we enter our email. So let's just say fakemail@mail.com. And then we enter a new password. So ASDMCHKL, whatever. Then we have to confirm this password. And then nothing happens. So obviously we should have also issued a print statement. But then if we go back here and we reload, here we go. We have a new user created with a new email, and it was created on July 23rd, and this considers it a sign-in using July 23rd as well. So now we just created this account, so that's pretty much what we have. The same thing could happen here, is that a username could probably also exist. Now, for the idea of password and confirm password not matching each other, we already validated it. Otherwise, we just want to validate the fact that a user already exists. So let's just do that. So what we're going to do is that we're going to try, and then we're going to print success, and then we're going to accept it by saying print username already exists, or let's say email already exists. So email. And now if we run it, so we enter our email. So let's just say dummy@mail.com, and pretty much like any password, and then any password, email already exists. So now we cannot sign in with this email because we have already created an account with it, so we cannot create a new account. So that's pretty much it for logging in and signing up. So that's all it takes to be able to create an account with an email and a password. So everything else is up to you to have these sort of tips and tricks to validate things, to try and accept things, and make sure that everything's working and you're not allowing the user to throw any exceptions and make your app crash. So with what we did, we sort of did not allow any exceptions. In an app scenario, you would here let the user you would let the application issue an error message in case your user already exists or something is invalid. So that's pretty much it for authentication. You now know how to access these, you know how to create one of these, how to sign in, how to just validate things, check if an account or an email already exists. So you're pretty much good to go. Now, the next thing we're going to do is that we're going to move on from authentication and actually start with storage. So let's just move to storage right here. Okay, so now let's start with the storage part. Now, the first thing we're going to do is actually we're going to comment the auth part out, and we're going to take the storage part and leave it here. So we're saying storage is firebase.storage. So the same thing that as we did with the authentication part, we allowed this variable called storage to actually interact with the Firebase storage on the cloud. Now let's talk about the storage, what it is, how it works, and then we can start coding. So going back to our Firebase console, to our Firebase project. So this is storage. What storage necessarily is that it's a place on the cloud for you to store your users' data. And by your users' data, I mean user files, like not just data for databases, but actual genuine files, like images, audio, video, document PDFs, Word documents, XML documents. You can use it for pretty much anything. So if you have an app such as Instagram and you want your users to be uploading images the whole time, you have to store it somewhere, right? Now, where that place is going to be, is that it's basically a cloud area for your Firebase project from Google Cloud itself, where you can store these different files. Now, to get started, let's just get started. We have to just have some rules right here. So now we'll just say done, and we create a bucket. So while we wait for this bucket to create, so let's talk more about the storage. So by using storage, you're allowing your users essentially to upload information to the storage without knowing about it. So they're uploading their photos to this storage without knowing that they are, because your code is doing it in the background. And then to view these photos, to view these files, they're actually also downloading from the storage or reading from the storage. And that's what we're going to do in this tutorial right here. So this is our job in this tutorial. So this is our storage. Alright, so it looks pretty much similar to authentication, except this part is for storing files. Now you can choose to upload files manually. You can create folders. So here I can create a folder called subfolder, and then it would be a folder within my main storage folder. So it's similar to a sort of Google Drive, but for your apps, if you want to think of it that way. So let's go back to rules first before we can actually start working with it. So for rules, you have to specify who is allowed to read and write to this. So let's just say true, because this is just testing, and we want to be able to apply and upload these different things. If true. And we want to be able to upload and read files without any problems, without even being authenticated. So this is our storage. Now we want to upload files to here, and we want to upload them through these different folders. So how we're going to do so is through the following. Now here's what we're gonna do. So let's just go back to the code and start working. Now here's what we have. We have 3 different sample files right here. So these files are first a dummy text file, so lorem ipsum, dummy text. The next one is a Shakespearean poem, and it's a snippet from a Shakespearean poem, and it's stored in a text file called Shakespeare. And the last one is the story of Google, so this is how Google was initiated as a company, and it's also stored in a text file. So we have these files, and this is our Python code, so this is where we're working. Now let's just say storage. So this is the storage part of the course. So here's what we're going to do. What we're going to do is that we want to upload one of these different files to the internet, to the storage in our cloud storage in Firebase. So how do we do it? How do we do it? First, we ask the user. So we have to say file name equals input, and we say enter the name of the file you want to upload. And then what we want to do as well, so cloud file name is also input, enter the name of the file on the cloud. Now the difference between these two things, I'll explain it in a minute. And the last thing you want to do is that you just want to say storage.child cloud file name dot put, and you would say file. So what is going on here? Let's just explain it. So by asking the file name, I'm asking the user to tell me which file, or I'm sorry, here, let me put file name. So I'm asking the user which file should I upload to storage. So if I say I want to upload shakespeare.txt, then I'm going to take this shakespeare.txt file and upload this to storage. What cloud file name is that what I want to name it in the storage. So here it could be called Shakespeare, but in storage I could choose to call it ABCD. Or I can give it a certain code word name, which I'll later utilize for something else. So this is pretty much how the dynamic of things sort of work here. So keep that in mind. Let's just run it and see what's going on. As for the storage.child part, so here we're saying, so storage.child, so this is the cloud file name, and we're going to put this file there. Now, if that's not pretty clear to you, it's okay, because when we demo it, this will all be clear and I'll re-explain it again. So running it now. So enter the name of the file you want to upload. So I'm just going to say shakespeare.txt. Alright, now I enter. Enter the name of the file in the cloud. So I'm just going to say books/poems/poem number 1.txt. And now I'm going to enter. Process finished. So what just happened? Why did I create this sort of path right here? Let's go back to storage, check things out, and see what really happened using this line of code right here. So going back to storage, now we want to refresh so that we can actually see what just got updated by running this last code instance that we ran. So waiting for it to come back. Here it is. So we manually created subfolder earlier. However, books, we never created it manually. Yet here it is because when I wrote this here, I created a books/poems/poem1.txt path. So this path gets automatically created, even if one of these files or folders does not genuinely exist in the storage. So books was created, opening it, poems was created as well, and opening it as well, we have poem1.txt. Now we can choose to open it right here. If we open it, we have a long URL right here, which stores this poem on the cloud, and there the poem is in a text file on the cloud in the cloud storage. So that's basically how you put a file to the storage. Now you can also choose to put a file without a subfolder. So running it, we can say we want to upload lorem ipsum.txt. Now what do I want to name it? I just want to name it dummy text.txt with no path specified. So process finished, meaning if we go back to the original part, here we go, we have dummy text.txt. It's outside the two different subfolders that already exist, and I can access it, and there it is on the cloud with having its own unique URL. Alright, so that's pretty much how you do it. Now, you know how to put a file. That's literally it. You can also choose to put an image file, a PDF, a video, an audio file. It's all essentially the same. Now, if you want to get this URL that we just posted, you can actually print it out. So print storage.child, and you can specify the URL. So cloud file name .get URL, and you would have to put a none type here. So running it, we can try with story of Google now. So story of google.txt, and then I want to enter the name of the file on the cloud. So let's say google.txt, and if we print it, here we go, we have this URL right here, which is the URL of the file on the cloud. Now coming back here, if we refresh, we can see google.txt was created, and we have this text file with the story of Google online on the cloud. So that's pretty much how you just put things. You can also get the URL just like I just taught you too. So what's next? So we know how to put a file on the cloud. How do we actually get it? So I want to download it. How do you let me download it? Child cloud file name .download. Now we have to specify a path to where we're saving it. So if I want to save it in this current directory, I just specify an empty string, and then I specify a name. So I can say downloaded.txt. Alright, so this is how I download. So what's going on here essentially is that I'm taking this cloud file name. So let's say, for example, book/poem/poem.txt, and I'm downloading it into this path, into this file. So let's run it and demo it and see what's going on. So as we can see here, we don't have a demo text file, download text files. So enter the name of the file you want to download. So if I want to say books/poems/poem1.txt, and process is finished, we have a new downloaded.txt file. It contains the same poem as the Shakespeare file, so we just managed to basically download it. Now, that's pretty much all there is to it. So this is how you would download a file. So let's just say download, and here we can say upload. So we learned how to download a file that we already uploaded in the storage. So we can also say, for example, by changing this, we can comment this out. We can say here, I want to download google.txt, which I already have in the storage as google.txt. Now, if I run it, it's supposed to essentially directly download the Google file. So going back to downloaded, now we have the story of Google within this downloaded text file. Another thing we can do is that we can actually read from a file when we know that it's actually a document, so a text file with a string. So since we already managed to get the URL, like right here, so let's just find that. So storage.get URL. So we can say URL is equal to this, and cloud file name is essentially the same thing. We're asking the user to give us the cloud file name. So let's just say this is reading file, and we just want to be able to read or print the strings directly into the command line without downloading it to an external text file. So you do this the same way you would do it with standard Python. So URL lib.request, I must import URL lib. Alright, .request.url open, and then we open it to URL.read. And then we want to just print f, because f will obviously contain a string. So running it, enter the name of the file that you want to download. So we want to download, say, google.txt. And here we go. Here's the story of Google begins, and this is where the entire story is printed to us as a string from the same text file by reading it from a URL. So this is the same as reading any text online files such as XML, JSON, or even TXT file from the internet. using the URL lib. So if you know standard Python, you're probably familiar with this. So that's pretty much it for the storage part of this tutorial. Now you know exactly what you need about storage and everything you need to be able to work with files, upload them, download them, and just manage them in general. So here we go. Now we're done. The next part is the database part. Okay, so this is the last part of this video. However, it is a bigger part mainly because of the different aspects that come with a database, mainly the different CRUD features, so create, read, update, and delete. So the first thing we're going to do is actually create a database. However, we do not want to work with Cloud Firestore. So the thing about Firebase is that it provides two different types of databases, the real-time database as well as the Cloud Firestore. Now, there are a series of differences between these two databases, and it would be too long to actually highlight these in this video. Now, I already have an existing video mainly tackling this topic, which is how to choose between Cloud Firestore versus real-time database, in which I highlight the differences as well as the similarities of these two very powerful databases. However, for this video, we're going to stick to the real-time database, mainly because the Pyrebase library only supports real-time database. It does not support Cloud Firestore. For Cloud Firestore support in the Python language, you'll have to go and use a different Python library to access the Cloud Firestore, which should not appear to be a problem for you because you can use multiple Firebase libraries within the same application and still manage to get the job done. And trust me, I know because I've done that for a project in which I used two different libraries, one the normal Firebase API as well as the Pyrebase library within the same project. Anyways, without further ado, let's get started. So let's just actually create the database. So we scroll down to real-time database and we create the database. So we want to start in test mode, meaning read and write are true. So anyone can be able to write and read data from this database, meaning you have my credentials, my API credentials, my configuration part from the beginning of this whole video. So from this very start, when we actually started with authentication, you can use those credentials and actually access my data and read and write to it. So my project will be shut down after this video is up. However, I'm letting you know that's pretty much how it works when you're in test mode rather than locked mode. So let's keep it in test mode for now and enable it. And now we wait for the real-time database to be created. So now we have a real-time database. This is our database, and this is pretty much what we have. So what this is basically is a huge JSON tree. So this is the root node, you could say. So this is a URL mentioning the root node. Now, if I want to create a node, I can create one right here and say name and just say John. And then if I add it, now I have a child node for this root node. And it follows this sort of JSON format in which things are key value pairs. So like Python dicts or JSON, which maybe you're familiar with JSON. If you are, then this is definitely a breeze for you. So JSON is key value pairs, and these key value pairs would be comma separated, and etc, etc. So I have a video on JSON if you're interested. However, I don't think you need to be just to be able to understand what's going on in this video. Anyway, so let's continue. So I can create something else here. So I can delve deeper into this hierarchical format by creating the following. So users, and then I can create a child node and then name this child node John. And then for John, I can create an age and say that he's 32. Now, if I add this, now I have, like, I can delete this original name John. Now I have this root node and a child node and another child node, another child node in which I have the information. So that's pretty much how it works. You just create these different children to other things, and then the leaf nodes would be actual data, actual information, such as maybe an age, and it could have an int or a string. So an age could actually be that he's old, and that's a string. Or it could be a boolean, so maybe not age, maybe something else, where I could say that whether he's employed or not, and I could name that as true. And I can save strings, ints, booleans, dates, and all sorts of different formats. So there are a series of data types. For more on data types, I have a video, however, not a necessity for you to watch it. Anyways, so let's just get started. So now that we know how the data is structured, we can actually go about actually working with it from the code. So what I'm going to do is I'm going to delete everything except the root node and just start fresh, start from scratch, and see how this works with the code. So for now, we're just going to start with creating data for this database. It's obviously empty since the root node has a null value. Now going back to the code, now we can actually get started. So the first thing we want to do is that we have to just enable this again. So let's just remove the comment, and comment the storage part out. So now we have db is firebase.database, and this is what helps us actually access this real-time database. And like I said, Pyrebase does not provide this Cloud Firestore support, so it only supports real-time DB. Now scrolling back down, we want to actually start by creating our data. Now the way this data works is that we want to, let's say, upload different data about different people. So let's just say that the data would be a person's, you could say, age. So we could say that this person's age is 40. And then however, you should have always strings for your key value pairs in Python. So like we said at the start of this video, if you leave this without a string, then you would necessarily be attempting to call in a variable with Python. So then you can say address, and then you can specify what this person's address would be. So let's say New York, and then you can specify an occupation, or actually let's just say employed, and specify this as true, and then you can give that person a name, and I'm just gonna name this person John Smith. So this is my early data that I have. Now to create data into the database, what I need to do is I have to db.push it. So db.push data, and that's pretty much all there is to it to actually create this data. So let's just run it and wait for everything to happen. So now that it's done, I can go back and check. Here I go. So this is a real-time database, meaning that it syncs in real time. There's no need to ever refresh anything. So here we go. This is the real-time database. We have a new object, which is a child node of the root node created, and it has this different information in it. So how does this work? So when I use the push function, it essentially creates a new child node of the root node that I specified. So I said db.push, right? So it essentially pushed it right into db, into the root node. db necessarily represents the root node. So I pushed right into the root node a new child node with a randomly generated ID that is somewhat dependent on the current timestamp. So Firebase does this for you. It's a unique ID. And then for this ID, I push a bunch of new objects and a bunch of items. These items are the key value pairs, which actually represent a single JSON object with different sorts of information. Now, I could have pushed this to a different part. So I could say db.child, and I would say people or employees or whatever I want to call my other node. And then if I run this and I wait for it to be done, if I go back to the database, I can see that people is a child node of this root node, and within it I can save the different people. It is good practice to have another node within your root node that contains everything. So let's just delete this one and actually follow that sort of path. But now that you know the difference between db. Versus db.child, so db. Represents essentially the root node. db.child means root node, .child people, .push data. And you can have infinite .child functions right here, creating more paths. So a person, and then you can push the data. So you can have .child, creating these different paths for yourself. And within these paths, you'll be able to travel within this tree in the real-time database. So going back here, we can see people. Let's just minimize this. So it's db.child people, .child person, and we pushed here, meaning an ID was created with the data within it. So now that you understand how this works, so you should probably understand how this works, how the push and the paths work for this, we can delete this and just focus on the previous format of following the people and pushing items inside it. So now that you know how to do this, you can have different combinations of the data. So you can change, let's say, age to 32, address to LA, and then you could say employed is false, and then just name this person Mark, and then just run this and be pushing more and more data into, sorry, I uploaded it into child, so let's just keep it inside people so it can all match. Anyways, what I'm saying essentially is that you can have all sorts of combinations for your data. You can prompt the user, so you would tell the user to enter your age, enter your address, enter your employment, enter your name, and then you would push all that data, formulate it into a dictionary, and push it to the database to the required location you want using db.child.people.push. So going back, now this was obviously an accident, so I'm just going to delete the person part. And this is what we have. So now we have two different people. Each one has their own unique ID, and then with the information within it. Now, what would happen if I do not want this unique ID. I want my own ID. So here's what I have to do. I change push to set, and I have to create another child here. So child.set. So what is this last child I've created? This child is essentially stating that I want to be inside this path, so I want to be inside root node dot people, but the next node I'm going to follow is not going to be a randomly generated ID. It's going to be my own ID, which I'm going to set through this child function. So I'm just going to say my own ID, and I'm going to set this data there. So let me just run it. And here we go. So going back here, we have my own ID within people, and it has this information about this Mark guy. So now you should understand the difference between allowing the push function to create this own ID for your data versus you specifying it with the set function. So when you say set, you're saying I want all this information to just be directly put under the last node I specified, which is here I named it my own ID. Could be pretty much anything. It could be just a random set of characters, and this set of characters should represent your ID. So by running it, if you go back, now you have another user, and this is your user. And this is the ID with the children part of it, which are the different information within this node. So like I said, now you know the difference between push and set. And these are the mainly two ways for you to create these, to create your data in the Firebase Realtime Database. So now we just finished the first letter from the CRUD part. So now we know CRUD, we know that this is how we create our data. Next thing we're going to do is actually skip over the R for now, do the update, then do the delete, and then finally do the read data, since it's the largest and bulkiest part. So stay tuned for that. So now it's time for the update part. So I want to be able to update this data that I just created in my database. So let's assume now I want to go inside this one. So knowing the ID is ASDFGHK, so JK. So this is where I want to update the name to Mark, from Mark to Jane. So how do I do that? So how do I change the name from Mark to Jane? So here's what I have to do. I also have to follow a path using the db.child functions. So I'm just going to say db.child people, we said, dot child, and here it's going to be this ID, which is what we specified to be the ID parent of this name Mark right here. And then we say we want to update, and then we specify name to Jane. All right, so now I can run it saying that I want to update name to Jane, and then I'll explain it in a minute. So running it, as we can see, Jane here, this one Mark was here and it was updated into Jane. Now, how does this work? Let me just explain this real quick. So like I said, we create paths using the child function. So we already know how to do this. It's the same as the create part. Now, obviously, let me comment this out so it doesn't bother us. Okay, so now that we have the update, we just decided by having an input document right here, or an input JSON, or an input Python dict. And this input here, this argument for this method, it tells us that we want the name part, the key here, to be this value, Jane. Now, what if I had said names? What would happen in this case? So let me just run it and show you what happens. Going back, now we have names, so it's a new one with the value Jane. So here's what happens. This update function, it checks whether this field or this key already exists. So here we have these different keys, which are address, age, employed, name, and we do not have names originally. It checks if it exists. So when it existed in the case of name, it just simply converts it to Jane, because here we're setting it as Jane. However, if it does not exist, as in the case with names, it just creates a new field and specifies this value. So it goes from being null to actually having a value. So that's pretty much how update works. Now, what's one thing that's concerning with this? The one thing that's concerning in this case is the fact that this ID here was known. Like, we specified this. So the coder here, the coder actually knows each user's different ID. Now, what would happen if I want to access this one, but I do not know exactly what this ID is? Now, how do I do that? So here's what I'm going to do. So what I'm going to do is that I'm going to just delete these and just assume I only have IDs that I do not know. So I'm just going to remove this since we had the same data. So now I have these two different person nodes. And now I'm going to go back to my code and then do this without the ID. So here's how I'm going to do it. Let's just say I want to put it in a variable, so people, and I say db.child people.get. So essentially what this function does is that it's taking all the people inside db.child people and storing them into one variable called get. Now to actually iterate over these, to actually understand what they are, we cannot simply just iterate over it directly. What we need to do is we have to say for person in people, or for I in people, doesn't really matter, dot each. So to be able to iterate, you have to use the dot each function. And now for this, we can print person dot val and print person dot key. Now why I'm doing this is that I want you to understand what information we have available at hand now and how we can use it to actually get the certain person that we want to update Mark for. So running it, let's just print it. So we have this value here, so address New York, age is 40, employed is true, name John Smith, and this is their ID. And I also have this value here, and this is their ID. So going back, we can actually check that this is the exact same information. This is the information in the val part of this function, and this is the information in the key part of this function. Now what I'm interested in is actually getting the key. So how do I get this key? I want to extract the key that is used for Mark, so I can use it to update the name of Mark into something new. So how I'm going to do it is I'm just going to specify that if person.val sub name, because essentially this is a Python dict, so let's just go back here. So this is a Python dict, meaning I can access these different key values by using the key in the sub part of this statement. So by saying person.val sub name, I'm saying I want to access the name here, either John Smith or Mark. And I want to say that if this name is equal to Mark, I want to actually update. So how do I update? So what I have to say is db.child people.child person.key, and then I specify .update, and I give it name should be Jane. Now I'll explain the code in a minute. Let me just run it and actually show you how it works. So going back, we can see that this name is now Jane. So here's what we did. So we went through the different people. So we extracted first the different people nodes. So for each person, we have a val and a key. The val being all this information within a person, and the key being this ID. Now, for the information within a person, I managed to extract it. And from that, I managed to extract the name. And I compared. So when the name is Mark, I asked it to actually update this name into Jane. And the way I asked it is that I created a path the way we just did it before, but instead of the key being known, the key is actually stored within person.key. So because this person actually has a name of Mark, I want their key, so I extract their ID, I perform the path, and then through this path, I actually perform the update. So that's pretty much it. That's pretty much how you do the update part and how you can actually do it. So like I said, it's pretty straightforward, it's pretty easy. That's all you need to know. Now you know how to update in two different cases, where you know the ID versus when you actually don't. So that's pretty much it for update. The next part we're going to do is the delete data. So let me just comment this part out and get ready for deleting data with Pyrebase. Okay, so now comes the time for the delete part. Now, the reason I'm doing delete and update together is that they hold a lot of similarities in the way that with delete as well, there are also two types of deletions you can perform. One with a known ID and one with an unknown and randomly generated ID. So first, let's start with the known ID. So let's just go back and create some manual data right here. And then inside people, we're just going to create a person. And then we're going to give this person some information. So let's say age is going to be 34. And then we're going to have a name for them. And that name is going to be Mary. And then we're going to have an address, and it's going to have London. And we do not necessarily need to provide an employment as well. So it can be pretty much anything, mainly because Firebase is a NoSQL database, meaning the different person nodes here the different objects within this database do not necessarily have to have the same schema or necessarily have to have the same fields or keys in a sense. So we can add this. And now that we have this, we know the direct, you could say, path to access the age right here. So let's say I want to remove Mary's age. How do I remove her age? All I have to do is db.child people and then .child person .child age .remove. Pretty simple, pretty straightforward. Now if I run it, I wait for it to happen, I go back, and the age part is suddenly removed. So that's all you need to do. You have to, in the case of a known ID, you just have to specify directly the ID of the things that you want to delete. You just go by it one by one and you specify this is the path I want, and I want you to delete the final node I have. Now what if I want to delete this entire person node? So you can as well delete an entire node with all of its children. So removing this child age here, and let's just say just remove, and if I run this, it should delete the entire person node as well as all of its children. You obviously cannot delete a node without deleting its children, so let me just run it, and now it's done. We can go back, person is gone as well as all of its nodes. So now you know how to delete something with a known ID. How do you delete something with a generated key? So to delete a node with a generated key, you follow pretty much the same logic that we used in the update part. So we also have to just, let me just actually copy this part right here, and I'll tell you what we're going to change. So you also have to store all the people you want in a variable. And then for person in this people, you have to specify, let's say I want to delete the one for John Smith. I want to delete John Smith's age. So I want to delete this guy's age. I want to remove his age here, 40. I want to delete it. How do I do so? So like I said, you check whether this name is John Smith. Now what happens if it is John Smith in this sense? What do I do? So I just db.child people .child, and I get John Smith's ID, so person.key, and then .child age .remove. Now that I'm done, I can run it. And here I go. So like I said, the age for John Smith is definitely deleted. So that's how you actually delete for both cases when you have the known key versus when you have the unknown or generated key. That's pretty much it for delete. There's pretty much nothing else you can do in a sense. So now we're going to move on to the read part, which is the last part of this tutorial of this entire course. And through this part, we're going to be able to actually understand how the read works, as well as perform some complex, more advanced queries on the data. So stay tuned for that. Okay, so now comes the last part, the read data part. So to read data, we actually have been sort of reading data throughout this tutorial. So when we were working with update and delete, we were doing the following. We were saying that people is equal to db.child people.get. And through this, I'm storing all these people, and I'm able to access their keys and values using the key and the val functions by iterating over each. So now that I know that, this is pretty much all I need to be able to retrieve data. Everything else is simply forming paths to be able to get this data. So if I want to get this, let's say, if I want to get this user right here, so I actually went ahead and can just copy this. I went ahead and created a third person just so we can have more flexibility in terms of our queries. And I can say .child, and I specify the ID here, .get. I can print the actual value of this. Now if I run it, I get an ordered dict with this information for this specific person because I pasted the ID. So you know pretty much how to work with these paths now. What we actually want is that we want to be able to create some conditions on this data to be able to access it and filter it accordingly. So I want all the people whose age is greater than 3. I want all the people whose employment is actually true. I want all the people whose address is in LA. So that's how we're going to work with it. Now, the way we're going to do it is that we have to actually work on these different fields or these different columns. To do so, we have to index these columns first. So let's actually go back to the Firebase and actually index these columns. To index the columns, we have to go to the rules. Going back to the rules, here's what we have to do. Now, the reason we have to go to rules is basically we have to define some indexes on the field names or the keys that we're going to be performing these conditions. So what do I mean by this? By performing these indexes, by creating them, we index on these names. So let's just go back and let me show you the data so this is more clear to you. However, you don't really need to understand the entirety of things, but it wouldn't hurt to truly get what's going on here. So these names right here, so address, age, employed, name, these represent these sorts of fields or this information about the data within people, right? So we already know this. So by indexing on these things, by indexing on age, address, name, and employed, that means I can query for conditions on these keys. So I can say that I want the age to be 30, I want the name to be Jane, I want the address to be in LA. So conditions like that. So conditions for querying. Without performing these indexes, it's virtually impossible for us to be able to perform these queries with Firebase. So that's why we go to rules and we add this new field. So here we add a new field that corresponds to the root node that we have. So the root node inside our original root node. So people, that's what we have it. So people, and then we create the value for it to be another object. And this object would have dot index on, and then within it we would list all the names of our fields or the keys that we're going to be querying on. So age, address, name, and employed. So now it can publish now that we've created this. So we wait for it to publish, rules are published, we can go back to our data and we can start working through the code to be able to actually perform these queries. So let's go back to the code right now and just see what we have. So I'm going to keep this because this is pretty useful, and except I'm just going to add some conditions right here. So let's say I want to actually check for the name. I want the name to be Jane. So here's what I have to do. I have to order by child. And then here I list the name of this field that I'm performing this condition on. So name. This could be age or address or employed. And on this field, I'm saying that I want to apply this condition. Now the condition is what follows. There are a series of functions that can follow the order by child. The first one is equal to. So I want the name to be equal to Jane. And now I can say .get. Alright? So here I'm saying that order by child name, meaning I want you to actually order my results, the results within the db.child people. I want you to order them by name and only get those who have the name equal to Jane. And that's pretty much how it works. So if you want, you can iterate over them. So for person in people, or you can even not iterate over them, but it's smarter to do this so you can see them listed in a sense. You can print the person .val, and by doing so you're printing the values of these query results. So let's run it and see the result that we get. So running it, we get the following. So we get two different people with the name Jane. That's actually because we have two of them. So we have Jane, this one with the address in LA and age 32, and we have the other Jane where the address is in LA as well, but age is 29. And we get these results, we have them printed in this sort of dict. So the person.val is a Python dict or dictionary. It's similar to sort of JSON syntax, and this is the information that we have. So we can see the key value pairs are separated by commas, and we can just sort of detect the keys versus the values. So that's pretty much how you do it. If you want, you only want to print the, let's say, age of all the Janes. So you can print person.val sub age, and by doing so, you'd be able to get the age of everyone who is called Jane. And we get the age of 32 as well as 29. We can change this to address and then run it, and then get LA and LA because both Janes live in LA. Alright, so that's pretty much all there is to it. So this is how you get to access different parts of your query results. So for now, let's just print the query results. So now that we know that we can order by child name, and we can verify that it is equal to Jane. Now what else can we do? So instead of equal to, there is another function that we can use. I'll go into it in a minute. So let's order by age. Age is an int. So if we want to verify, age is an int. Here it's 32, here it's 29. Here there is no age, so it's pretty much null. Going back to the code, we can say that the age should be equal to 32, right? And now if we print the result, we have only one result. It's the following. So Jane has an age of 32, address of LA, employed is false. Now, I don't have to just measure equal to. So I can say start at 30. And by doing so, I'm saying I want everyone whose age is greater than or equal to 30. So the age starts at 30. So here I should get one result, which is the Jane with the age of 32, since the other one has an age of 29. Now, if I change start at to say 25, and I run it again, I get both Janes. Alright, so that's pretty much how we can do this. Now, one thing to note is that start at is greater than or equal to 25. We also have dot end at, and we can put all of these in a sort of string of different functions, just all following each other, and that way we can combine these different combinations. So the age, also you could say ends at 30, so we want those whose age is between 25 and 30. In this case, we get one result. So this is how we sort of do it. So this is how we perform these conditions on the age, on the int. Like here, you can tell that the condition, we're saying 25 as an int and not 25 as a string, because that's not what we're doing. And that's pretty much it. Now we can also verify that the Boolean, which is employed, so let's say employed is equal to true. So dot equals to true, and then we get it, and now we can print it, and this is what we have. So we get John Smith, who is employed, true, and Jane, who is employed, true. So the Jane with age of 29 is actually employed. So that's really how you do it. Now, there are different sorts of conditions you can have here, so between equal to, as well as start at, end at. Another thing you can do is that you can limit the number of results. So here I'm saying they're equal to true, so here I have two results. Maybe I want to limit this result to 1. Dot limit to first 1. So limit to first 1. By this, I'm saying that I want the top 1 result of this of these employed different people. So by doing so, I get the first one, which is John Smith. I can say limit to last, and also get the bottom one in this case. So here I get Jane. So you can also combine this with what we were doing with measuring the age by saying it's greater than 25, and I could choose to get only the top 3 people who have an age greater than 25, for example. So this is how you combine them. Now, one thing to keep in mind is that we're ordering by the child. So when I say order by child, I'm saying that I want to order by this field, by this key or this key value pair. So I'm saying I want to order by employed or age or name or pretty much anything else. And I want this to have the following conditions. And this is where you would have your series of functions for the conditions. You can have equal to, you can have start at, end at, you can have limits at the end. So you can say I want to limit to the last 5, to the first 3, to the top 10. This is essentially how you do it. And in all cases, you finish with a get function. And when you do finish with a get function, you can iterate over them using the each function and print out the value. And you can just deal with the value with pretty much anything. So by actually accessing it like a Python dict. So going back here and changing name to employed and just keeping limit to last one and then running it. Here we can access the name of this person by printing person.val sub name, and this is how we access that person's name. So by knowing these things, by learning these things, you're now pretty much ready to have any sort of query within your application and perform these operations on it. By doing these queries, you can filter your data, extract relevant data, as well as extract certain data with respect to relevant data. So here we're extracting Jane with respect to the fact that she is employed, and that is true. So now that you know this, you're pretty much done with the retrieving data part. So thank you very much for watching this very long course or tutorial where we learned authentication, storage, and finally the Firebase Realtime Database. We learned these different CRUD applications, and now you have all the tools necessary to start developing apps with Python using Firebase and using the Pyrebase library. So thank you very much for watching. Please leave a comment and a like if you enjoyed, and I'll see you in the next video. Bye bye.